Okay, so let us go through this problem, then it will be clear how to analyze a problem of projectile motion. So the problem shows projectile launched at a velocity of 10 meter per second at some angle 30 degrees to the horizontal. The path of the projectile is shown, and the first part of the problem asks us to find the maximum height reached by the object. To find the maximum height, we can just analyze the vertical motion independently. We don't have to consider the horizontal motion. The vertical motion is just under acceleration due to gravity, which is constant. So we can apply the equations of motion, but we need to find an initial velocity in the vertical direction, v naught y, and we can use vector components to find that velocity. In this case, we see v naught y equals 10 times sine of 30 degrees. Comes out to be 5 meter per second. So when the object has reached its maximum height, its velocity is 0 because it is just about to turn back and fall down, right? Final velocity is 0, and it's always under the acceleration of gravity but in the vertical direction, so a equals minus g. Then we can apply this equation, v square equals v naught square minus 2gh, which we derived a few slides ago. And we need to find h, the maximum height. So everything else is given. We know v naught y and the initial velocity in the y direction. We know the final velocity in the y direction is 0, and so we plug in all the numbers. V naught y is 5 meter per second, and we get 1.27 meter for h, the maximum height that the projectile reaches. Now the next part of the problem asks us to find the total time of flight. The total time of flight can be solved from this other equation, the equation for position and time for constant acceleration that we also derived a few slides ago. When the particle has traveled and fallen to the ground again, the vertical displacement y minus y naught is 0 actually, right? So in this equation, in this quadratic equation, we can plug in y minus y naught equal to 0, and we can solve for t. We know v naught y also, as we have seen, it's 5 meter per second square. We know the values of g. All we need to find is the values of t. So we set y minus y naught equal to 0 and solve for t. It's a quadratic equation, so we have two solutions. One solution gives us t equal to 0. So this is the initial instant when the projectile was launched. We are not interested in this solution. We are interested in the other time when y minus y naught equal to 0, when the projectile has reached the ground after its flight. And the quadratic equation also gives us this solution. This is equal to 2 times v naught y over g. V naught y is 5 meter per second, as we have already calculated. So we get a time of flight of 1.02 seconds for the projectile. This problem doesn't ask anything about the x direction, but if you were to find the maximum distance traveled in the x direction, you can easily find that because the acceleration in the x direction is 0. So the particle is always traveling at constant velocity in the x direction, and we know the initial velocity in the x direction also, right? So it's just the other component of the velocity vector, v naught x, given by 10 cosine 30 degrees. So this gives us 8.66 meter per second. If you were to find this distance x that the projectile travels in the horizontal direction, you can just multiply this v naught x by the time of flight t, which we have obtained. So which is something like 1.02 seconds. So this will give you the range through which the projectile travels. The range is basically the horizontal distance the projectile has traveled.